Here we go. All right, so I'm Doug Davis, work at IBM. I work on SIG Service Catalog. I'm actually a maintainer and co-lead of the project. And basically what we're going to do here is provide a very quick overview of the project itself. Tomorrow, Jonathan will be doing a deeper dive. So if you're interested in more than the superficial stuff I'll cover, come back tomorrow for Jonathan's session. So let's talk a little bit about applications. Because in a cloud-native world, people like to think of stateless applications, and they don't really think much about what they have to do to actually get their job done. In particular, most applications are really 100% stateless. A lot of them will talk to back-end systems. The most common use case is talk to a data store, right? And so some sort of database. And the critical point here is that these applications or these ancillary sort of services that your applications talk to are very important and critical for your applications to get their job done. But ideally, these aren't the things that developers should actually have to worry about, right? They should focus on their application and getting their business logic done. They shouldn't have to worry about talking to databases or setting up databases and all that other stuff, okay? So before we go a little bit further to talk about how we're going to make life easier working with these services, it's important to understand that the word services is actually overloaded, right? Kubernetes has the word services, which kind of means endpoints, right? Or when you take your application or your pods, you can expose it as services. That's one type of service. But that's not the type of service that we're talking about here. The service that we're talking about are services that are used by applications that are either managed, for example, by the platform, say by Kubernetes or your cloud provider, like a blob store kind of a thing, or an object store, or external services that are outside your platform, like something hosted on the internet, like, for example, Twilio, okay? So it's really these two types of services that we're talking about, these last two, right? The ones that are Kubernetes managed, those are already kind of done for you. Those are easy to find and discover. Kubernetes manages that for you. It's these last two that I'm more actually concerned about when I talk about services going forward. And I just want to make sure people understood that. So let's talk about accessing these external services, okay? It's actually kind of challenging for people because each individual task I'm going to talk about by itself may not be that hard, but when you put it together, it gets to be kind of cumbersome. So for example, when you start talking about your application needing a service, well, each individual project or each team is going to have to go through the exact same process. So that means each team is going to duplicate all the work necessary to actually set up these external services. So you get this duplication of effort. But then if you hand it off to an ops team to manage it for you, well, then you're at their schedules and timelines to set up these things for you, right? So then maybe they set up a database for you, but then how do they get you the credentials or the information you need to actually talk to the service, right? Do they send that to you through email in some unsecure fashion? How do you then manage those credentials going forward, right? Do you put them into configuration files? How do you get them into your application? These are all decisions that you are going to have to make at an organization level and at a project level. And when you combine that with the fact that every single service that you're going to talk to will have its own set of APIs, its own way to get provision, its own way to manage credentials, it just becomes very cumbersome and annoying. And these are all things that the application developer really should not have to worry about, right? Again, this is going back to the notion that application developers should focus on their business logic, not managing these services that they talk to, okay? So let's talk about another option here. What if we were to shift this around and say, application developers, stop worrying about these things. What if you instead just tell us, meaning us as the platform, what services you would like for your application, and we will provision it for you, and then we'll provide you the credentials or information you need to talk to the service at runtime. You don't need to worry about how to get that information. You don't need to worry about You don't need to worry about how to get the information, about how to store the information, about how to secure it. It will just be made available to you, and we'll manage all that for you, okay? So let's talk about a what-if type of scenario, okay? So what if you, as an application developer, could run one single command, like svcat marketplace, and it returns you a list of services that are available to you that are, in essence, known to the platform. So in this particular case, we have a MySQL database and a Mongo database. They have these things called plans, and you could think of plans as sort of like a quality of service kind of thing. Free is the low tier, and if you're going to pay for it, maybe you get higher quality of service, better HA, that kind of stuff, okay? So you have a list of services that are available to you. Simple enough. What if you then said, okay, provision me a MySQL database? I'm going to call it MyDB. I'm going to ask for the MySQL, and I want the quality of service called, or plan, called free. Simple enough. Then I need to tell it to actually bind my application to that instance of the database that I just created. In this particular case, what this bind operation is going to do is create a secret for me inside Kubernetes with all the credentials and access information I need to talk to that database. So with these three simple little commands, what I'm left with is a secret inside Kubernetes with all the information I need to talk to it. I didn't have to do any of this myself manually. I didn't have to go figure out how to provision MySQL, figure out how to get the credentials, figure out how to provision a new instance of MySQL beyond just installing it, or how to create a new instance of a database. It's all done for me under the covers and managed by the experts, not me as a developer. I just do three simple commands and I'm ready to go. So before I actually show a demo about all this, let's talk a little bit about how this all magically happens. There are a couple of different ways to look at this. First is from the administrator level. Obviously, in order for you to look at something like this Service Cat Marketplace command, something has to register these services with the platform, okay? And that's what this administrator is going to do. So the administrator is going to register what we call service brokers to the platform. And each service broker will advertise the list of services it offers and what plans for each service are available to you. And that's pretty much it. The platform, in this case Kubernetes, will take those and expose them through a marketplace type of thing, which is the svcat marketplace command that we show over there, okay? And that's really it from the cluster administrator level perspective. From the developer perspective, as we said, what they're going to do is they're going to choose a service for the marketplace. That's the provision MyDB command. Kubernetes will then talk to the broker and say, provision the database for me. And that's it. Later on, when I do the bind operation, what you're basically telling Kubernetes to do is say, okay, go back to the broker and say, for that instance of the database I just created, give me a new set of credentials because I have a new application that wants to talk to it. And what that means is you can actually have more than one application talking to the same database. And that broker will then decide if it's going to share the credentials across these applications or give different set of credentials for applications. The broker kind of decides whether it's multi-tenant or not. But the point here is that the broker and Kubernetes manages all this information for you. As the application developer, I just issue those three commands and then the magic happens. And like I said, you're left with a secret with all the information you need that you can then use in your application. So how does all this happen under the covers? We actually leverage a specification called the Open Service Broker API. Now this is an API that was originally developed by Cloud Foundry for this exact purpose of managing the interaction with services. About a year or so ago, maybe 2 now, I can't remember exactly how long ago, they actually said, well, let's stop making the specification just for Cloud Foundry. Let's open it up to the broader community. And in particular, Kubernetes jumped on board and said, hey, this looks really cool and interesting. We're going to join the community and help promote it and implement it as part of Kubernetes environment. And that's how we got the service catalog stuff, okay? But the API itself is actually relatively simple. You can kind of think of it as the basic CRUD or the CRUD type operations for services, right? Create the service, delete the service, bind and unbind, those kind of operations. Very, very simple things. All it does is standardize just those 4. So as long as you can get by with just those operations talking to your service, you can play in this game, which means any service that you want to offer up to your customers or application developers can probably fit into this model in a relatively easy fashion. Okay, so as I said, it abstracts the lifecycle APIs of your service. What does that actually mean, though? What it means is that the service broker will manage all of the aspects of these services for you. So it's not just these ones that are in bold, which I call user-initiated, right? We talked about those already. The user is going to initiate the provision command. The user is going to initiate the bind command. Those are the ones that the application developer does, and those are the obvious ones that will be sort of managed for you or done for you as you ask the platform to do it. It's the ones that are below that are actually really, really critical beyond those. So for example, the owner of the MySQL service broker will actually auto-scale it for you, okay? It will do backups for you. It is their responsibility to manage all aspects of the service on your behalf, again, so that you as the application developer don't have to worry about it anymore. That's the other key aspect of all this. It's not just the cool user experience through the command line that we're talking about. It's this magic that goes on behind the scenes that you as the application developer no longer need to worry about. And in particular, as the application developer, you don't need to worry about where the service is actually hosted. It could be hosted in your Kubernetes cluster. It could be hosted on their side of the world. It doesn't matter, and you don't care. Again, it's an abstraction, pushing it out, so you don't have to worry about this stuff anymore. So, why are we doing all this? And I kind of touched on most of these already. One of the biggest reasons for doing this is to focus on the application developer's ease of use, right? Allow them to focus on their application development or their business logic and not the services anymore, okay? Let the services be managed by the experts and switch to a self-service model, which should speed up the development time for your developers so you can get your product out to market faster, okay? Now, I talk about a lot of this from the application developer's point of view, and that's all true and that's good. But let's also look at it from the service provider point of view, right? The guys who are offering it, the MySQL, the MongoDBs, those things. What's in their best interest? Why do they want to do this? Well, because the APIs that we're talking about are so basic and easy to implement, there's a low barrier of entry for them to play in this game. Why is that good? Well, because what it means is if they just support these 4 little APIs, they can now have their service exposed to any platform that supports the Open Service Broker API, like Kubernetes. And they can get integrated really, really easily into all those platforms. They don't have to recode any new APIs for every single platform. So they get an interoperability statement for this portability and ease of use. So, and when that ease of use happens and people can start using their services more and more, people will switch from, say, the free tier to the paid tiers. So that these service providers can now start making money off of these services. So it's a form of advertising their services out there very quickly with these free basic tiers, but then it's an up-ramp to the paid ones, so they can make money as well, and with a relatively low barrier of entry. Okay? So let's quickly run through a demo, if I can do this right. Okay, now this is actually live, even though I'm not going to actually be doing the typing, but it is actually a live demo. I'm just going to let the computer do the typing for me. So first, we're going to do this svcat marketplace command. And it's just to refresh your memory, that's going to show you all the services that are available that I registered through service brokers into my Kubernetes cluster. So when I run the command, you see I just have 1 service registered, 2 plans, free and paid. This is just a demo service broker. It's not a real thing out there. But it does implement the APIs, which is all that really matters. So, okay, so now what we're going to do, we're going to provision an instance of the DemoDB class, use the free plan, and I'm going to call it MyDB. So this is going to tell Kubernetes to go off to that service broker and provision a brand new instance of DemoDB. And you can see it returns some interesting information back to you, just for fun. Now what we're going to do is we're going to bind it. This is going to go back and tell Kubernetes to talk to the service broker again on my behalf and ask for the credentials for how do I actually talk to this instance of my database. So it did it, and it waited for the bind to complete because there's a little bit of actions that happen, right? He has to talk to the broker. He has to then create the secret. Could take some time, so we waited for it to finish. So now let's go ahead and take a look at the secret that got created. By default, it's going to create a secret called MyDB as well. So if you look at it, you can see it's a normal Kubernetes secret, nothing too exciting. But if you look at this data right here, you got password, URL, user. That's the information that Kubernetes got from the service broker. That is the service instance specific credentials that I need as an application developer to talk to that database. So if we actually get that secret, get that property out of the secret and base64 decode it, you'll actually see that the URL field is a real URL and it's going to be talking to my cluster. Okay, so now let's go ahead and take a look at this YAML file. So this is the YAML file from application to be deployed. So how do I get that secret into my application? The normal Kubernetes way, right? I have normal container for my from application. I bind the secret into a volume called creds, and then I bind mount that volume into my container at /creds as the mount path. Normal Kubernetes stuff, nothing new and exciting there. But let's take a look at my application itself. So my application, very small little application, but notice these first few things. I'm going to get the URL, user, and password of how to talk to the database from the files on disk that are injected because of the secret. Then I just go ahead and use them. I create a new database with the connection with the user ID and password. I then do a DB set, so I'm setting property 1 to hello, and to verify it actually worked, I do a DB get to get the property back out, and I just print it. Very simple application, but it shows you connect to the database, set a property, retrieve the property, print it out just to make sure it worked. So let's go ahead and apply the YAML to deploy it. Wait for the pod to get there. Okay, so the pod got started, it ran, and notice I have a little sleep 300 at the end there, so it will actually stick around for a little bit, so we can actually do a Kubernetes log on it to see the output, and you'll see, here's the user information, user ID and password from that print line right there, right? And then we do a new connection, we say storing, we get the value back out, hello. So there we did it. We had a simple application, retrieved the credentials, and the connection information to talking to the database, and I didn't have to do anything manually relative to actually getting those credentials. Everything is retrieved for me dynamically at runtime. So as I take this application and run it through my CI/CD pipeline, whether it's in staging, testing, or production, I don't need to change my application. Somebody else is going to set up this database for me, and all I need to do is bind to it when I actually go do my deployment through the use of secrets. Everything's sort of managed for me outside my application. Application developer doesn't need to worry about it anymore. That's the benefit of all this. All right, so let's keep going with the demo, or with the slides. All right, so I showed you how to do this stuff through a simple svcat command line. Now, svcat is actually a tool that the Service Catalog project put together just to make your life easier, because that's what we want to do. A lot of people who are new to this stuff may not necessarily be comfortable with all the YAML that Kubernetes forces you to do. But once you are become an expert in Kubernetes or proficient in Kubernetes, you're more used to dealing with YAML. You can still do all the exact same things through the command line, that you can do through the command line through YAML. And if you look at this, it's the same thing. When I create a service instance, I provide the name of the instance that I want to call it, the type of class, and the plan. So it's the same information, just in YAML form. When I go to do the binding, I'm going to get the same information. I'm going to create a service binding. I'm going to give it the name of MyDB, just like as before, but I'm going to reference the instance called MyDB, which was created up here. Exact same information, nothing terribly exciting or controversial. It should be pretty obvious. But if you're not comfortable with the command line and you want to do everything through YAML files or stick this in your Helm charts, you can do that as well. It should still work. Okay, so with that, sort of let's summarize what we talked about here. So why are we doing all this stuff? We're doing this to make life easier for the developer so they can focus on their business logic and not have to worry about managing of these ancillary services that are critical to their application's business requirements, but they themselves shouldn't have to worry about it. Okay, so this allows them to focus on their business logic with faster time to market. All you need to do is figure out how to talk to your platform to say, give this thing for me, and then magic happens under the covers. And that's the whole point of all this, make life easier and speed things up. So the project itself is an incubator project inside Kubernetes. You can deploy it to any Kubernetes cluster via simple Helm charts, and right now it's in beta form, or it's in beta status. We are getting closer and closer to version 1, but we're not quite there yet. Hopefully before maybe mid next year we may get there, but it all depends on how we finish out the open features, or feature requests. So that's sort of the quick status. Now, before we actually adjourn though, one thing I want to say about services. I talked about this with a database example, and using services like database or some sort of data analytic kind of thing are probably one of the more common use cases or the types of services that people will actually use this for. But I think it's important to understand that when you start talking about services, they actually can be just about anything you want that even may not be related to an application running inside your platform. So for example, let's first talk about the applications though. What you could do is talk about a service that maybe isn't going to inject credentials into your application so you could talk to it, but maybe that service is going to manage your application for you, right? Maybe the service isn't about injecting credentials, maybe the service is about auto-scaling your application. So that service will then talk back to the platform, inspect your application at runtime to see if it's getting overloaded, and do automatic scaling for you, right? The service, depending on how it's written, could do a whole bunch of things for you. As long as it can talk to the platform and interact with the platform on your behalf, the aperture of what you can do is actually wide open, right? So you can do utilities like speech to text, conversion type stuff. integration things, infrastructure operations. You can create volumes, auto scaling, set up networks automatically. The service could do just about anything for you. And in particular, the DevOps, what I mentioned before, like the auto scaling type thing. So think about services beyond just what your application needs to get its job done. Think about services that are maybe for use by the platform itself, right? You don't have to think about these things just in the terms of applications. Because once you do, you can start really opening up the aperture. And with that, I think we're basically done. Here are some important URLs. I think the slides are available to you guys on the website right now. So the first one is just a nice URL to the Service Catalog documentation. Here's the incubator project itself inside the Kubernetes repo. The specification itself, the Open Source Broker API, is the third one. And if you're interested in joining and participating in the work itself, we are going to try to have some China-friendly meetings on a regular basis at 11 a.m. China time, starting on the 19th. So if you're interested in joining, please try to join at that time. And as I mentioned earlier, Jonathan, my colleague, will be talking about this stuff in a deeper fashion tomorrow at 11:30 if you guys have additional questions that touch on subject that I didn't talk about here. And with that, I think we're basically done. Are there any questions? No? Oh, yes. Mm-hmm. I'll repeat the question, yes. Do we have a microphone for him? You want me to use the mic for him? Okay, there we go.
So basically my main question is about the deployment of the service catalog. Mm-hmm. So like in 1 year ago, I remember there's like a pre-request for setting up a like service catalog with like API extensions. So I remember in the slides you have mentioned that we can deploy with a Helm chart. Mm-hmm. And so my question is, how is that like, does it require any pre-request for the Kubernetes cluster? And is that compatible with like most majority cloud providers like Microsoft Azure and AWS or any like native like Kubernetes clusters?
Yeah, correct me if I'm wrong here, but I believe the Helm chart will work on any generic Kubernetes cluster. In fact, when I ran the demo, I was using the Kubernetes kube-up command from the source tree, right? And that's a generic Kubernetes cluster or install. And I just ran the Helm chart on there. So obviously the prerequisite is you have to have Helm installed. But once you have Helm installed, you run the Helm chart or deploy the Helm chart, and it works right out of the box. There's no other prerequisites needed.
Thanks.
Yep. Yes, Zong.
Hey, Doug. Great talk. This is Zhong Tian. So when you earlier said that this is a open API now, who is maintaining that service catalog API?
No, so the service catalog is the Kubernetes implementation of the Open Service Broker API. The Open Service Broker API is a cloud. I'm trying to get the right terminology here. It's under the Cloud Foundry Foundation. It's a new PMC, I think might be the term. It's a separate project under the Cloud Foundry Foundation, which is there just to develop the specification itself. And then it's actually implemented, obviously, by Cloud Foundry, Kubernetes, and actually other people are implementing as well outside of those environments. So for example, IBM and I believe SAP support that API outside of, say, Kubernetes as part of the base platform itself. So Open Source Broker API, separate organization under Cloud Foundry Foundation, Service Catalog, incubator project under Kubernetes, which is an implementation of the Open Source Broker API. Make sense?
Thank you.
Yep. Good question. All right, any other questions? All right, I think we're done then. Thank you very much.